electrostatic potential and capacitance. We'll discuss dielectrics and polarization. Do you know the dielectric word? Dielectrics and polarization. We're going to discuss about this. Basically, dielectric, you know that dielectric are non-conducting substances. If you say what are basically dielectric, dielectrics are non-conducting substances. Okay. And you know that if we write the definition, so we even can write dielectric is a substance which does not allow the flow of charges through it, but permits them to exert electrostatic forces, on one another through it. And a dielectric is actually a type of, we can say it's an insulator which can polarize through the localized displacement of charges. So you can polarize a dielectric. Now if I ask you, what is the behavior of conductor? That is, behavior of conductor and dielectric in an external electric field. If I ask you what is the behavior, so just we'll see that what happens if, say, this is a conductor. Okay. Now if you apply the external electric field in this, you know that this is what E naught, and this will pass away. Inside the conductor, if you remember, the net electric field is 0. Now today you will come to know how. This is electric field. What will happen? All the negative charges will be here and all the positive charges will be here. Then this is sigma here, and this is plus sigma, and this is minus sigma and plus sigma. And this electric field is passing through it. But do you know what happens? And opposite electric field comes. It's an E induced. And this is E naught. And both have same value. Okay. So what happens? Net electric field becomes 0. So this is the reason why, because they oppose one another. E will be the difference of what? E naught minus E induced. Both are same. It is the case of what? The conductor. But do you know in dielectric what happens? If I show a diagram of dielectric, say this is a dielectric, and again you are applying what? External field in it. You are applying external field in it. Say this is E naught. You know what happens? The electric field E naught is passing through this one. But this time there will be a charge, but this charge will be having which density? Do you know? The induced charge density. And again the electric field E naught will have the direction. This is an external electric field. There will be E induced opposite to it. But this time E induced is less than E naught. So net electric field will not be 0. This is the difference between what? A conductor and a dielectric, because there is some polarization inside it. So a conductor has net electric field because the electric field induced and the external are what? Same, but directionally opposite. Here electric field external and induced are not same. Induced is a bit less. So this will have non-zero electric field. So this is how dielectrics and polarization. Now there are two type of dielectrics. One is the polar and another is non-polar. Like we have polar and non-polar molecules. Have you heard about the polar and non-polar molecules? They themselves forms what? Medium, and that medium is known as polar or a what? Non-polar medium. Now we know that if a molecule, if a molecule in which the center of mass, of positive charges does not coincide with the center of mass of negative charges. Negative charges means electron is called polar molecules. Polar molecules. So these are the polar molecules. Like we know that the polar molecules are like this, in which center of mass does not. So they are like this, minus, plus, or they can be like this. These are the polar. But then when we talk about the non-polar molecules, like HCl, we know that H2O, these are the polar one. But then non-polar, how we define a molecule, in which the center of mass of positive charge coincides with the center of mass of negative charge, that is electron. Negative charge. Okay, so negative charges. So what happens is called what? Non-polar. And non-polar molecules, non-polar dielectrics is the word. So if I ask you what will it be, this will be like this, plus minus or minus plus, like we have N2, H2. These are the example here, HCl, H2O. So these are the polar and non-polar dielectrics. So can we polarize the non-polar? Because polar are already having the dipole moment because they have a gap, but this one, the answer is yes. So we are going to talk about that only, and then we'll come to know about the behavior of dielectric in external electric field. That means if the molecules are like this, plus minus, plus minus, plus minus, plus minus, plus minus, in any, say this is a what? A dielectric. So then what happens? As you apply the electric field, here electric field is 0. But when you apply the electric field, they will become like this. When you apply the external electric field, they will be deformed like this. Like this. They have now what? Deformed. Under what? External electric field. We have applied external electric field here. Got it? So that is how they are showing their behavior. This is the case for polarization of what? Non-polarization. This is called polarization of non-polar what? Dielectric. It was a non-polar dielectric. How it changed? The electric field is applying, so this will deform it. Got it? So how this non-polar dielectrics come in this? In the same way, we know that these are the polar ones, 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 like this. This is now electric field external is 0. But now you again apply it. Say this is again polar. You apply it. Do you know what will happen? You see that as you apply it, this will be again like this. The negative will come on this side. The negative will come on this side. The negative will. So already they have a dipole moment. So here they have applied an external. This is polarization. This is polarization of what? Polar dielectrics. This is under what? External electric field. So got it? Polarization of non-polar and polar. We are basically going to talk about the non-polar. There we come what? That dielectric constant. So just I will show you what is how it behaves. So how the polarization comes in a what? Non-polar dielectric. We are talking about non-polar dielectrics. Okay. So non-polar dielectric, we are talking about non-polar dielectric. So how this happens, I will show you. Say this is a positive plate and this is a negative plate. Okay, so certainly the external electric field will be in this direction. You have this what? A non-polar dielectric slab. You put it here. Do you know what will happen? When you put it here, this positive will attract the negative side. So it deforms like this. It deforms like this. It deforms like this. Now I think you got it. What happens? This positive will attract the negative of this non-polar dielectrics. Then what happens after this? Because external field is there. After this dielectric slab will have what? All the negative charges on this side. You got it? Negative is going on this side and positive will be going on this side. And this is external electric field. And do you know what will happen? Inside there will be what? Induced electric field. What we are talking about? Induced. And external is going on this side. And ultimately what will happen? That this is positive plate of the capacitor. This is negative plate. And you know that ultimately the net electric field will be what? In this side only. Okay, this will be net electric field. Can you tell me why? Because I told you that E induced is less than E naught. So net will be E naught minus E induced. And it will be along the direction of electric field. And this is the dielectric slab of K. You remember dielectric constant? So can we write what? E is what? E naught by K. Can we write like this, that E is represented by E naught by K. Already we have defined K, dielectric constant. So this E is this. So this phenomena is known as what? Dielectric polarization. You took a non-polar molecule, you put it here, then what happens? All the negatives will go on this side. Positive because of the external field, it will become a negative and it will become a positive end. But this will have what? Less field. So this will be the field net and it will be. Okay, now polarization density. Polarization density. There are two words. One is polarization density and another is what? Electric susceptibility. So just there's a definition. It is defined as induced dipole moment per unit volume. So you know that there is a induction in dielectric. So this is a term defined. So that means P is what? P is induced dipole moment upon volume of the plates. So P, induced dipole moment, is QP into D by AD. AD is the volume. So D cancel out. It is QP by what? A. And this is sigma P. Now do you know what was sigma P? Sigma P is the induced. Sigma P and sigma induced is same thing. So this is the charged which was induced. And do you know what is dipole moment? You remember charge into the distance between the plates. So P is what? Polarization density. 1 mark definition comes from this part. Now there is another one, electric susceptibility. These two terms have come here in dielectric and polarization. So electric susceptibility, it is denoted by XE or chi E. So here what is this? The polarization density P is directly proportional to what? Do you know the electric field inside the dielectric? So well, P is directly proportional to E, so we'd say that P is, and there will be a constant, and that constant is chi E, and this is what? The electric susceptibility. So it is actually the ratio of, we can write it is the ratio of polarization and the electric field inside the dielectric. So inside the dielectric. Okay. So chi E is P by what? E. It is the ratio. So this is actually a unitless quantity. So this is what? And sometimes you have heard about the third word, dielectric strength. You will come across this word also. Dielectric strength. Now what is dielectric strength? You know that it is the how we define it, the maximum electric field. That is the maximum electric field that can exist in a dielectric without, you know, that there is a breakdown, without causing the breakdown so of its insulating property, because it has an insulating property. You remember dielectric. So without the insulating property is called dielectric strength. Is called dielectric strength. 1 mark, you know, these are the definitions. So dielectric strength, susceptibility, and you know that every medium has a dielectric, like one of the medium is mica. Mica has a dielectric strength of 160, and the dielectric constant for mica is 5.4. And same is what for air we say that what is the dielectric constant? It is what? For air it is 1.000054, but we take 1, and here it is what? Do you know? 0.8. So these are the three things: dielectric strength, susceptibility, and polarization density. Now we'll talk about the capacitance, very important derivation. Capacitance of a capacitor in what? Dielectric medium. This is a very important derivation, because we have discussed about dielectric polarization. Now we'll do it. Say there is what? A capacitor, and you know it has a positive charge, it has a negative charge, and there is an external field. You remember it is sigma by epsilon naught, and now you place what? A dielectric slab in between it. And you know that in dielectric this is a dielectric, and what is the electric field? I am writing directly here, E equal to E naught by K. What is K? K is what? Dielectric constant. Okay, got it? T is the thickness of the medium, and D is the distance between the plates. So these things are given. What is again I am writing is that sigma is charge per unit area, A is area of plate, okay, D is the distance between the plates, and what is T? T is thickness of the dielectric medium, thickness of dielectric. It is how it behaves here. And K is what, and even you can write what E equal to K. So we can have that K dielectric constant. And all of you know that we have already proved E equal to E naught. K we have defined number of times dielectric constant. And this is a dielectric. How the capacitance will come. Remember, what is as Q equal to what? CB. C is the capacitance. Say we consider C as the capacitance in dielectric medium. So in place of Q, what we can write sigma A equal to what? CB. C is, what is the potential difference now here? Very interesting. Potential difference. Now potential difference are of two types. One is inside the plate, inside the dielectric medium, and one is between the plates. So potential difference is what? Electric field into distance. So how I am going to write it? E naught into distance. What is the distance for E naught? Do you know? D minus T. So it is D minus T. It's not D, it's D minus T, the gap. And what is the distance for the electric field? It is T, so E into T. So very interesting. This is the potential difference. You remember, potential difference is electric field into distance. So we know that this is the main part. So sigma A, we'll write C in place of V. We get what? E naught D minus T plus what? E into what? T. This is this. And now how we are going to get? So we know that sigma A is equal to what? C and what? E naught D minus T plus E into T. And then sigma A, you remember, E naught D minus T, and in place of E you can take E naught by K, and E naught will come out, D minus T plus T by K. And you know sigma A, what is E naught? Sigma by epsilon naught. We have gone through E naught is sigma by epsilon naught, and in place of E you can write E naught by K. You have written here. So this will be, and T will be common, so 1 minus 1 by K. So sigma cancels out. It is epsilon naught A C D minus T 1 minus 1 by K. So at the last, what is the expression? Epsilon naught D minus T 1 minus 1 by K. So this is the expression of the capacitance in what? Dielectric medium. Remember, dielectric medium. And one is very important, that C is less than C naught. What was C naught? C naught is the capacitance in air medium. Air medium, you have already done it. It is epsilon naught A by T. So T is what? Thickness. K is dielectric constant. This is how you get the capacitance. Again, I am repeating, you have taken a dielectric. In dielectric, we now know that this is the electric field. And then Q is CB. Q is sigma A, CB. What is the main thing is the potential difference. Here there are two parts. One is between the medium and one is between the plates. So this will be written in this way. And then we know that how we replace E naught and E. And finally we get what? Capacitance. So in next video we are going to discuss about the conducting medium and numericals related with this. So go through it, and thank you. Regularly watch my video.